my screen to you. All right, so it looks like you're seeing the sketch of the swivel stop. Okay, so the new things on the swivel stop are, I've got a little pointer here. I think I can mark with this pen. Right here, we have a new geometric dimensioning and tolerancing symbol. Okay, and it looks like a circle, and it has a plus sign drawn on it, like that. And this is called tolerance of position, 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 okay? And what it's telling us is that this hole right here, this diameter 50 hole, there's actually two of these guys that are diameter 50, but because of the location of the feature control frame, I know that this geometric dimension and tolerancing only applies to that top hole, the 0.50 hole. And then there's a counterbore hole that has a diameter of 0.88 that goes to a depth of 0.25. But the GD&T does not apply to them because it's just in line with the diameter 50 hole. So that means this GD&T only applies to the smaller hole that goes all the way through the swivel stop, okay? And the way we interpret this is it says, position this hole right here, this 0.50 hole, inside a cylindrical tolerance zone that has a diameter of 0.035 when this hole is at maximum material condition. So you see that circle with the M in it? I think we've discussed a couple of times that indicates maximum material condition. And so to continue on with the interpretation of this, it says position this 0.50 hole where its center axis runs through a 0.035, so that's a 35 thousandths diameter cylinder. Okay, and so this cylinder, it's very small in diameter, and it actually represents, a target for the center axis of this hole to run through. And this applies when that hole is at maximum material condition. And then it tells us relative to datum A, datum B, and datum C. Okay, so we're going to talk more about this on Monday when I have the whiteboard and we can get a little more into it. But this is tolerance of position, and this is the most complicated geometric dimensioning and tolerancing concept that we're going to discuss this semester. So let's look and see if we can find where datum A is. And what we see is that datum A is actually the back side of this part. Now, of course, it's not the back side of the part, it's the back side of the part put up against a datum plane. And so this is our most important datum plane because it's in the first slot right here. So we call where A is located right there the primary datum plane. So when you have a hole like this 0.50 hole and it's drilled in this direction right there, and you see that your datum A is your most important datum, what it's telling you is that to the designer, the most important thing about this hole is that it be cut perpendicular to datum A. All right, so we've talked a couple of times in here about when you drill a hole, how hard it is to hold a drill perfectly perpendicular to a plane. And of course, we're not using a drill to make this thing. We're probably using a CNC mill or something like that. But the point is that however we cut that hole, whether we bore it or drill it, our primary concern is how perpendicular it is to datum plane A. And datum plane A is like a horizontal datum plane in the background there. And that's usually your primary datum on holes is perpendicularity, is the plane that would be for measuring perpendicularity, because I think I've mentioned that when holes are drilled crooked, and then you've got another hole and it's also crooked, and we call that crookedness, we actually call that attitude, that if you try to put a bolt through both of those holes, that's where you're going to have the maximum amount of trouble assembling two parts as if the holes are not within a tolerance that controls their perpendicularity. Okay, so essentially we're trying to make sure that the center axis of the bolt can go through both holes, even though the hole's center axis may have some attitude to it. Okay, does that make sense to you guys? So hopefully it will. Like I said, we'll talk more about this Monday. We'll talk about this a lot because tolerance of position is really an important GD&T concept. And so after you make this drawing and after you make future drawings, you're going to have drawings where tolerance of position on GD&T is going to be in those drawings. And if you use those drawings in your portfolio, and if you can explain that stuff in a job interview, it's real powerful, okay? Because there's not a lot of people who can explain geometric dimensioning and tolerancing, especially of tolerance of position. Yeah, Jason, go ahead.
So I had a question about your the datum references. I know this is a stupid question, but I got stuck in my mind and now I can't stop thinking about it. So you have them ordered in the data control frame for ABC, showing which one is more important
Right.
for the design process. So if for some reason the engineer labeled them, ABC in this order, but came and said, hey, this one is most important, put C first, would it be more, the proper is the only word I can think of, would it be more proper to put them in, C, A, B, or whatever order you want?
Yes.
Or would you go back and reorder the datums so that the important one was first, but now it was A, and then B, and then another C?
That would be up to the designer. The designer could do that, or in the case of this one, you could go C, A, B, or C, B, A, whatever your order was. If C were your primary datum, and since C is this plane here, we would imagine that plane against a datum, right, pushed up against a datum. And what would be the most important thing? Well, it would actually be the location along that axis right there. So if C were your primary datum, the designer would be saying, the most important thing to me is the location of that hole from C, right? So that would be like a vertical measurement right there, so it wouldn't be a perpendicularity measurement. So your other question was, could you just go ahead and label what we now have as C, label it as A? Yeah, you could do that. The thing is, a lot of times on parts, A may be referenced by several different holes or something, so in that case, it might preclude you from doing what we're talking about right now. This part's pretty simple because it just has those two holes. So yeah, we could do something like that.
Okay, thanks.
Sure, that was a good question. So yeah, so when we look at this A, B, and C, the way they're ordered in that feature control frame is the order of their you could think of it as their importance. And so whatever's in the first box, and which in this case is A, right there, we call that the primary datum plane. Whatever in the second box, we call the secondary datum plane. And if we have a third box, in order of importance, that's what we call the tertiary datum plane. So tertiary, see if I can spell it with my writing tool here. Oh boy, it's going to give me a hard time to just write. So TERTIA. Oh, that's supposed to be an A. R. Oh man. And a Y. Tertiary. Okay, so what that means is, it's a fancy way of saying that is third in importance. So we've got primary, secondary, and tertiary. But you can imagine if you actually use the term tertiary in a job interview, I think you would get their attention, that if you knew it to that level. And so that's sort of my goal for you guys, is that we talk about this enough that you could explain tolerance of position in a job interview. Okay, so to continue on with explaining the tolerance of position in this one, so I said that A, which is on, would be the back plane and controls perpendicularity. Well, what is B? Well, B is coming in from this side over here. So we would look for, we'd be looking for a dimension that would give us how far in from B that is. And here's that dimension right here. It is a 1, but the 1 is in a box. And so whenever you have a dimension in a rectangle like that, it means it's a basic dimension. Now, what a basic dimension means is that it's theoretically a perfect dimension. So if the location of this cylindrical tolerance zone that we have right here were perfectly located from B, it would be exactly 1 inch over. So what we're talking about here is the position of the center axis of this diameter 50 hole that we have right here. That the center axis of that runs through a cylinder that's very small. It's 0.035. That's perfectly perpendicular to A. So the cylinder, which is like a target, it's our tolerance, it's very small, it's perfectly perpendicular to A, and we want the center axis of this hole to run through that. Now, it can have attitude, but it can't lie outside of that 0.035 diameter cylinder. That cylinder is also, the center of that cylinder is located perfectly from B. So that would mean if that cylinder were located perfectly from 1, that would give its location from this side over here. And then our third datum, which is the tertiary datum of C, C is on the top right here. And so if we look, we find the dimension that would locate the center of that hole. It's this 1 right here that's also inside a box. So that's called a basic dimension. Basic dimensions are like considered to be perfect dimensions. There's no tolerance on it. So we know we can't build anything perfectly, but what we're saying here is that if we could perfectly locate a tolerance zone, and if the tolerance zone had a diameter of 0.035 and was a very small cylinder, and that cylinder were perpendicular to A, and if the center of the circle were located perfectly 1 inch in from B and 1 inch down from C, that would be the true position for our hole. Now the hole doesn't have to be perfect, but the center axis of the hole has to run through that 0.035 cylinder that we see right over here, you know. And so that's what the tolerance is for the hole. The hole can rattle around inside that 0.035 millimeter diameter cylinder, okay? So I know that's a lot to put together into one feature control frame, but if you can explain that, it's very powerful, you know. And so I think I mentioned that when Boeing came down here and recruited, and they saw that our students could explain tolerance of position, it like blew their minds, you know, because hardly anybody knows tolerance of position when they graduate from college. So that's one of the things we wanted to make sure that you guys would understand. And so we started in 1433, and we're going to continue to talk about tolerance of position in more advanced mechanical courses if you decide to be a mechanical major. All right. So we actually have a second hole on here, which is this hole right down there. And the center of that hole, this same GD&T note applies to this hole here. And so, but this time, the location of that hole is also a basic dimension. It says it's 3 inches from the center of this hole, which was also located with a basic dimension right here. So you can see we actually have 3 dimensions right there that are basic dimensions. So we have regular dimensions that we call the nominal size because we can have a plus or minus tolerance on them. We have reference dimensions, which are in parentheses, and reference dimensions are just included as a reference. Then we have basic dimensions that are part of geometric dimensioning and tolerancing, and these are like theoretically perfectly located datums or features that we can dimension to, okay? So right now that's probably a lot to be on your plate this early in the morning, but we'll get to it especially next week when we're back in class, we can talk more about this. So the goal here is to get these dimensions on this project between now and next Monday. So on Monday, I'm going to have a check print, and so you can check your drawing on Monday. And so I wanted to show you a little bit about, oh, there's one other thing I wanted to point out to you on this we haven't seen yet. It's this thing right down here, CF. What CF stands for is continuous feature. And what a continuous feature note like that tells us is that this feature, in this case right here, this plane right here and this plane here actually lie in the same plane, okay? So, you know, we might infer that they lie in the same plane, but by putting that CF symbol on a drawing and putting it on that extension line, we're actually really telling the manufacturer that these two surfaces, in this case, are coplanar, all right? And so, you know, one of the things we want to avoid is implying things. We don't want to imply stuff on a drawing. We want it to be clear that what we're saying is actually a fact. And so by putting CF and saying that, you know, when two features span a distance, that it's a continuous feature, that's one way to clear that up. Okay, so I'm going to go over here and we're going to look at, so I've got a prototype drawing open. Now, I've graded a couple of your drawings, and one of the things I saw, there was a few things like leading zeros are still showing up. They're showing up in dimensions, and they're also showing up in feature control frames and things like that. So I want to warn you about that, about making sure that you don't have your leading zeros in there. And actually, if you have your prototype open, I'll show you, you can go in and set that stuff ahead of time if you want to. And the way you do that, there's a tab right up here on the top of your screen if you have your prototype open that says Manage. And when you pick on Manage, right below that, there's an icon that says Styles Editor. If you click on the Styles Editor, it takes a few seconds for this to open. All right, so when the Styles Editor opens up, you can look over here on the left-hand side, and let's look at center marks, for example. So there's a bunch of different center mark styles you can have. The one that we're using, that everything's defaulting to right now, is ANSI, A-N-S-I. And ANSI is the same. You can think of it as ASME in a way. But so if we're doing the ANSI center mark, I'm just going to pick on that one right there. Pick on center mark. And we can see what our normal settings are. And by that I mean these are your default settings for the size of a center mark. And also they're the size for center lines that run through holes through the axis of a hole. And so just as a general rule, the value of A, which is the width of a center mark like that, we're almost always going to set that to 0.1. All right, so it's going to be 1/10 of an inch. And then the gap we're going to set to 0.05. So we're going to set that to 500ths or 50 thousandths. And we can probably leave the others okay. And then what you do is come up here and pick Save if you did that. And that would automatically set those for your center mark. Now I'm not going to do that on mine because I might use this as an example for something else. So I don't want to already have those set. But another thing that where you can go to is if you go to, let me go down here. If you go to Dimension and you look at ANSI, let me find ANSI on this guy. Right here, default ANSI, right here. And I'm going to pick no, I don't want to save those. So on our ANSI dimension style, right here under units, it says leading zero and it says trailing zeros. When you're dimensioning in inches, or the customary units of the United States, which is what we refer to as customary units, or they're also referred to as imperial units, you would want to uncheck leading zeros right there. And that takes those leading zeros out of your dimensions. So some of you, like for example, you handed in a drawing and instead of it saying 0.75 for a dimension, Yours said 0.75. Well, that 0 is leading 0. And you don't want to show leading zeros when you're working in inches. Now, the thing that's a little confusing about this is when we're working in the metric system and we're writing dimensions that are less than 1 millimeter, we do put a leading 0 on there, but so far we haven't had a metric drawing, so we're not doing that. So you would definitely want to undo this leading 0. And another way to undo or to set these things is, let me just cancel out of this guy real quick. Let's say no, go back to here. If you go to a dimension and you right click on it and you go to edit dimension style like that, it will open up that same dimension dialog box that I had open. And so if you pick on units, you would uncheck leading zeros there. So, you know, the way to fix dimensions once you start placing them is just to right click on them and then go to edit the dimension style. So if you have a center mark you're trying to put in, let's say it's this center mark right here. If it doesn't look right, right click on it and go to edit center mark style. And it takes a second to open. And so you can see that A is set to 0.1, B is set to 0.05, and then sometimes you have to manipulate C and D and these other guys, but always start by setting A to 0.1 and B to 0.05 and see if that fixes things. All right, so let me go back to here. All right, so remember we were in the styles editor, so I'm going to open that guy up and show you a couple more places, because if you set these in the styles editor in your prototype, you won't have to set them again because they'll become part of the prototype drawing. So the other one, feature control frame, and we don't want leading zeros in our feature control frame. So if you click on that and you click on units when that opens up and you uncheck leading zeros, then it'll take those out of feature control frames. The other thing on a feature control frame is, you know, that's that rectangle. You don't want that rectangle to be too big. You want it to be based on the text height. And so when you look at your text style right here, it says symbol size and it says scale to text height. Well, to find out what your text height is, click on that pencil. And when you get right here and you look at your text height, you want to set your text to 0.125 or 0.120, depending on the text height you're using for your dimensions. It should be the same. So if it's set to 0.2, that feature control frame box is going to be large because the text height drives the size of it. So I would change that right there. And I'm going to scale down or scroll down here. Another one is, let's see, we should have our datum ID. So the datum identifier, when we click on it, there's no leading zeros we have to deal with in that one, but the size of it is also based on text height. So if you go here and you click on that pencil, you would come down here and set your text height to like 0.125. And let's go back to our dimensions. So I'll just make sure, let's see what my dimensions or my dimension style is set to on this. So let's see, text. My text height I have on this guy, the default is set to 0.12, and I think we set ours to 0.125 the other day for our text height. So you would want all of those to match. Okay, so we'll get further into this and how you set up your prototype with all this stuff in it. So when you make this drawing, though, I wanted to point out a couple of things about it. So when you go to place your views and you go to the base view and you go choose the swivel stop, let me find it right there, you pick open, that I would choose this to be my principal view right here. And if it comes in at 1, at a scale of 1, which would be full scale, you can see that's going to be too big if you try to put another view of that. And so, you know, as a drafter, sometimes you have to just play around with the scale. So you could type in 0.75 for your scale. And even that looks too big if you try to put a top view, or you can maybe put a side view on it. So I'm going to double click on that and come back to it. And right here where it says scale, I'm going to try 0.5. I'm going to try half scale for this. And then I'm going to move that guy right over here. All right. Now, I want to put a projected view. So I want the top view to be right here. So I'm going to go over here and pick on projected. And I'm going to move straight up and go right up in this area in here. I'm going to pick and then right click and pick create. And I'm going to do another projected view, and I'm going to come off of my front view like this and pick. And I'm going to right click, create again. I'm going to drag that guy over here. And then I'm going to double click on it and I'm going to shade it. So this is going to be my isometric view. And I'm going to keep it at 0.5, so it'll be shaded. But I'm going to go to display options, and you see that line right up there? That's the tangent edge. I'm going to uncheck tangent edges and pick OK. Oh, come on, why aren't you shading? You should be shading. There we go. All right, so that's what I want my isometric view to look like. So I can put all these dimensions on this particular part just by dimensioning the front view and the top view. You don't need a right side view. In fact, you don't really gain anything by doing a right side view of this guy, because if I do a right side view off of this, I do a projected view off of that and pick and create, really, I don't see any good profiles in that, and I see some visible lines and some inlines, but I don't really get much out of that for dimensioning, so I'm going to delete that out. But when you look at this view, of course, you're going to see those counterbore holes. You're going to see this big arc. You're going to see these angles. So all of that's going to go there because those are good profile views. And in the top view, you have this slot. Remember, we've got a 0.25 by 0.25, and you're actually seeing it, in its profile view. So you're going to definitely put some dimensions in there. And so what I would do, if you look at the top view, I would go to annotate, and I would put that center line bisector, and I would choose this hidden line and that hidden line, and you can see it's putting in a center line bisector. Then I'm going to press escape. And so what you want to do, you want to bring that line out a 1/4 of an inch out past the edge, and you want to bring it down here 1/4 of an inch outside the edge of this. And so with Inventor, it's hard to know, well, what's 1/4 of an inch? Well, this slot right here is 0.25 at this scale. So as long as you come out about as far as that slot is, you should be safe on that. Now, if you right click on that and you go to Edit Center Mark Style, and you let that guy open up, this is where we want to set that center mark to 0.1, and we want to set our gap to 0.05. And then pick save and close, and that makes this a little bit shorter and just makes that look a little bit better. Now out here we need center marks on these guys, so I'm going to use the regular center mark, and if you choose the radius, it will draw a center mark, but only for the radius. So you have to also pick on the larger hole or the counterbore, and then do the same thing down here and pick on both of those to get those in. And then you'll need a center mark for this big arc that you have over here, okay? And we're going to dimension all those things. So what I would start doing is adding dimensions to this. And as I said up here, this is a good example of where you have a profile view of that slot. So I would start by putting a dimension from that corner there to this corner, and then bring it down and let it snap. And the distance that you have right here for that first dimension, according to the ASME rules, that should be a minimum of 0.4 inches, okay? And so by letting it snap, you're probably going to be out at least 0.4. But the other thing you want to do is when you place other dimensions, you want to use the same distance that you're using right there, just so things look good when you finish this drawing. So I'm going to do another dimension, and this time I'm going to go from this corner to that corner right there, and I'm going to place that guy on there, and I'm going to line it right up on there. Now, what you can do, I'm going to press escape on this, you can actually drag that over like that right there, so you can have this dimension on that side and this dimension on that side. So what's wrong with that dimension? Well, it's got a leading 0 on it, right? And so we can't have leading zeros when we dimension in inches. So what you could do is right click on that, go to Edit Dimension Style, let that open up. What you want to do is under Units right here where it says Leading Zeros, you want to uncheck that and pick Save and Close. And now you can see that it takes that guy out. Now to finish dimensioning that slot, now we know where its location is. We will put another dimension in here, and this time I would go from that corner there to this corner, and I would bring that dimension out somewhere out here. So I don't want to put it in here because it might be on top of my view, and I don't want that. And another dimension I can put on this view is going to be that 1.5. So I don't want those guys to overlap each other, and I don't want that 1.5 to run through that arrowhead right there. So what I'm going to do is I'm going to put my 1.5 there, and then I'm going to drag this guy out if I can. Let me see if I can drag this guy out. Should be able to, if I can catch it. Come on. Well, for some reason that guy doesn't want to drag out, so I'll just delete it and put another. Oh, I don't want to delete my old view. I just want to get rid of that dimension right there. There we go. So I'll just put a new dimension in. So I'm going to go from this corner here to that corner there, and I'm going to drag it out past. So if it doesn't move, you can always put a new one in. And so I don't want it to be crowded in there, so I'm going to move out a bit and place it about right there. And the other dimension I would put in here would be from this corner to this corner and get my overall. And another dimension on this view would be this dimension here. And so this is where when you move out and you let it snap, you see that distance right there? That distance and this distance right here should be equal. And so if I'm going to do that, I can see that this guy looks a little bit closer than those. So I could even drag, and press escape. I could drag this guy out a little bit farther, and in that case I might want to drag this guy out. Now I don't know why this is not letting me drag this dimension. There we go. So I got it on the extension line. It let me drag that out. Okay, so you see this distance between this dimension and the 6. I should try to use that same spacing over here, right? Because consistency is what makes drawings look good. And so you're going to find out that, like, you go to work in an office, there's some people whose drawings look great, and there's some people whose drawings are, while they may be okay technically, they don't look as good. And the ones that look good are the people that are using consistent spacings and things like that. Okay. All right, so down here on this view, I just wanted to show you about those reference dimensions and some of that other stuff. So, you know, what I would do down here is I would do a dimension from this corner here to the center like that, and I'm going to come out here like that and pick on it, and I'm going to zoom in on that, and I'm going to pick on that and go to precision and go to basic. See right here? So what I did is I picked on the dimension, and when the dialog box opened up, you can double click on it if you need to, and then you're just going to choose basic dimension. So, you know, if you have the sketch in front of you, I don't know if you can see me over there in your window, as I put all these in, I'm taking my highlighter and I'm just knocking these off. I'm highlighting each one as I place it because I want to make sure that I get every dimension in here. All right. So that's the location of that hole from B, although we haven't put B in there yet. And the next one we want to do is do a dimension from that corner there to the center of our hole and move it out and let it snap like that. And that should also be a reference. So I'm going to double click on it and go to precision and tolerance. Did I say reference? It should be basic. All right. So now I've got both of those guys in there. And then I'm going to put another dimension from this center to this center, and I'm going to line those guys up and double click on that because this should also be basic. And if I look on my sketch, I can see those dimensions, so I'm going to take my highlighter to them, and I'm going to make sure that I have all those guys in there now. So I have those 3 dimensions, and one of the things I need to do is add my B, C, and A datum identifiers. So you can go over here and find your datum identifier. So I'm going to pick on my down arrow right here. This is my datum identifier, and I'm going to pick on this dimension right here, and that one's actually going to be B when I get it in there. So I'm going to highlight that, change it to B. And then I need another datum identifier on, I want to put it on this top of this guy right here. So let's see, get that highlighted there. Bring that out here. That one's going to be C. And hopefully Inventor's going to let me move those out. So I'm going to press escape on those. So I want that to be like that. I want this, it's going to be lower down here. Now let's see if I can drag it out. There we go. Get that guy out there like that. And take B and drag it up and fine tune it a little bit. Bring this guy down like that. So now I have datums B and C, noted. So I would highlight those guys. And then I need to put A in, and I know that A is actually on this top edge back up here. So when I pick on A, I can pick either on the part itself, on the edge like that. Oh, come on. And bring that up. And it is A, so I don't need to change it. And then press escape. But then I would turn it and make it uniform like your other ones, and then I would highlight that. Now remember, if your text in your box, if that looks too big, what you would do is right click on it and you would go to Edit ID Style. And remember, it's based on text height. So when the dialog box opens up after you click on Edit ID Style, you would go right here to Text Style and you would pick on that pencil, and you would make sure that your text height matches your dimension text height. Okay, and that would change the size of that box right there. All right, so I've got almost all my dimensions in here with the exception of the stuff for this large arc over here. But what I do need to put on here is a hole note. And so I'm going to do this hole note. And if I do that hole note, I can't run it through all of this stuff over here. And so when I say that, first off, you shouldn't do that. And if you do it, I'm going to mark it up when I grade it. I'm going to say, don't run that leader through a bunch of stuff. So you got to find a place where there isn't a bunch of stuff. So that would probably be somewhere over here. All right, so all of that looks good, but I need a feature control frame on it. So I'm going to go feature control frame. And remember what you do, you pick, and if you don't want an arrowhead, as soon as you pick, you right click and you pick continue. And that opens this guy up right here. And so my symbol is going to be tolerance of position, which is that symbol right there. And my second symbol that I want to put in here actually is going to be a diameter. Okay, so I was following my way across, and then I want to 0.035. And then after that, I need a maximum material condition symbol in here. So if I look right down here from where my symbols are, I can pick maximum material condition. And then I've got A, and I have B, and I have C. So this is what my note looks like. All right, so I'm going to pick OK and press escape. So do you see anything wrong with my note? Okay, so I see two things right off the bat. One, it's too big. And second, it has a leading 0 in it. So I need to edit this. And once I edit it, all the other ones will be okay if I put more in. So to edit it, I need to right click on it and go to Edit, Feature, Control Frame Style. So how many people you think are on the planet today who know how to do all this stuff that we're doing? There aren't very many. That's a good thing. That makes it more valuable. Okay. So if you pick on units, right here where it says leading 0, we're going to uncheck leading 0. Okay. Then we're going to go to general right over here, and the size of the box is based on text height. So we're going to go to text style and pick on that pencil. And it says, do you want to save the edits? We're going to say yes. It takes us over here. So we look at our font is Arial, and there's our text height, 0.2. We're going to change that to 0.125 and pick save and close. Now we're going to drag that. If I put it right there, that would mean that applies to the entire, that would also apply to the hole and the counter bore. So I have to be careful about that, because if you do that, they'll actually inspect the counter bore too for perpendicularity. But this is where we're going to place it, is right up here in line with this guy right here. Now, how many of those holes do we have? Well, we have 2 of those. So we're going to have to come in here and we're going to have to add. So I'm going to uncheck use default, and I'm going to type 2 and a capital X and a space and pick OK. So I want 2x diameter 5. Now I'm going to drag this guy over, and I'm going to keep it lined up perfectly because I want my drawing to look really good. And I'm going to highlight all that stuff that I have it in there. All right, now the way things are going, because of some dimensions I need to go out here, this might get a little crowded. So that tells me I need to drag this view, my top view, straight up a little bit. And I don't want to go too high up there, but I may have to drag this note up higher, and which means I need to move that guy with it right there. Okay, so I need to put a dimension on here for full radius, just like we did the other day. So I'm going to put a dimension on, hang on here, didn't quite go in the way I wanted to. Let me do this one right here. All right, I want to put this guy in here, and I need to right click on it, press escape, right click, and go to options and put the arrow on the inside, because that's a fairly large arc right there. And I'm going to right click on that. I'm sorry, going to double click on that and go to text. And what I'm going to do is I'm going to hide my dimension text, because what I'm going to write here full is going to be full R, like we did the other day. I want the full radius of that arc. And so what that means is wherever that hole is placed, I want the full radius of that to go from this plane here to this plane right here. Okay. So I'm going to pick OK on that. So, and also because there's 2 of those, I should write 2x in there and a space. Oh, my X was not capitalized. Now a space and pick OK. So then I would highlight that because I have all that stuff on there. All right, so I just need a few more dimensions on here, and those are the ones that are going to define this stuff out here on the side. Okay, so let's just quickly get through those guys. So I'm going to do a dimension from this edge here to this edge right here, and I'm going to place that like right up here. And I want it to be in line with this guy right here. It looks like it's going in a little bit higher than that one, so I might have to do some fine tuning. But ideally, these would be in a line. And then I need another dimension from this corner here to this center mark right here, and that's also 1.5. And I want those to line up perfectly, just like that right there. Okay, so this plane here and this plane here are the ones that say that that's a continuous feature. So what I'm going to do is go up here where it says Insert Sketch Symbol, and I'm going to pick on that. And we already have a feature in there called Continuous Feature, and I'm going to pick OK. And you're going to come right over here, and you're going to set the continuous feature right on that line. Just try to center it as best you can, just like that. And then, oh, you're going to have to right-click Continue to get it on there, and then press Escape. Now I'm seeing this looks still a little bit crowded, so I'm going to go here and move my node up, which means I need to move my feature control frame up. All right, so I would highlight the CF and the 1.5s, and then I'm going to need a dimension on this, and I'm going to put it, I think I'm going to put it about right here. And I want that text to be sort of in the center like that. And then I need a dimension from this edge here to this angled line that I have right here. Now, let me do that again. I'm going to pick on this edge and on the line. Don't go get that green dot. Pick right there, and you're going to move out into this area right in here. And we're going to double click on that because we need that to say 2 capital X. So we actually need it to go at the end, 2X, and a space, and pick OK. Now let me tell you something about these spaces. If you say 2X space, you need to say 2X space down here. Again, it's one of those consistency things. And so when you go to work for someone, they were probably going to have somebody whose job title is checker, and the checker is going to give you a hard time about all this kind of stuff. And you'll eventually learn, and you'll stop doing it because you'll get tired of the checker marking all your drawings up and also making fun of you because you keep repeating the same mistakes. But here's the dangerous thing about repeating mistakes in the real world. Let's say your company times get lean and they decide they're going to lay somebody off. They'll probably go to the checker and they'll say, which one of these drafters makes the most mistakes? And the checker knows who's the worst drafter in the room and will tell them, well, this one guy, he repeats the same mistake over and over again. So that's the thing, make great drawings, make them consistent, don't have mistakes in them. So make it difficult for the company to lay you off because you are the best drafter there and they don't want to lose you. Okay, that would be a bit of advice on how to approach this and how to think about it. The other thing is, and I was thinking about this before I came into work today, is just if you make a mistake on a drawing and that drawing gets all the way out there to where people are making it, it gets to the production floor, and then they realize there's a mistake, it's going to be very embarrassing for you when you have to own up to a mistake that you made. Okay, so it's better to try to avoid making those mistakes. So we have this 0.75 right here, and we definitely have 2 of those. So we're going to do a 2X and a space. So now I'm going to highlight that guy, and I've got that, and I've got that. So what I need is a couple more dimensions, and then I'll be almost finished with this guy. That would be from this corner to my center mark. And probably what I'd want to do is line these dimensions up that I have right here. So I would press escape on that, see if I can drag this guy out just a little bit and try to make sure, just so it looks good, that those guys are lined up. And one of the things I'm missing is the overall width of this. So I'm going to put a dimension on from this corner to that corner, and I'm going to bring it out. And again, now I'm going to look at how far apart I spaced my dimensions up here. And I want to do about the same here. But this is kind of tight where that 5 and this extension line is. So I'm going to press escape. I would actually drag that up a little bit and offset it. Okay. Now, I think I have every dimension on here, but you guys will have to dimension yours, so you'll get a chance to highlight every dimension that you have. And so hopefully if you see something that I've done incorrectly, you'll fix that. Now, you can run a center mark all the way down through here, but you definitely want to come a 1/4 inch past the edge of this but this part is symmetrical. If I were going to put a center mark all the way down it, I would probably use the center line bisector like that right there, and then extend it out, and then extend it out maybe in this direction right there. So it actually looks like a center line when it runs all the way down through there. So if you include that, you might want to do something like that. I doubt you would have to do it that way, but okay, so initial release, that's the first release of a new part. So you can double click on that and go right in here, and you can fill out today's date and pick OK. So be sure you put a date right in here. And then down here, we're going to double click here, and the material of this part is machine steel. Okay, so when that comes up, we're going to type machine steel down here. And I don't think there are any other notes we need because I think all our scales are going to be pretty much the same and all. So when we fill out the title block, I noticed several of you guys are doing weird stuff in your title block. One is when the DR by, that's where your name goes. That's drawn by. You don't want your name to go into the border. If you do, I'm going to mark it up and take 1 point off. So I would recommend that you use your initials or your last name, or maybe even your first name. Or, you know, sometimes in an office, people have nicknames and they'll put their nicknames in there. But this is one of the few jobs where you actually sign your name to the finished product, right? And that's one of the cool things about it, I think. But if you look over here in your tree and you expand under the A&E CAD title block and then double click on field text, right here where it asks you for the name of the part, where is the name of the part? That's weird. I'm not seeing. There it is, drawing title. Okay, so what I'm going to do right here is type swivel stop, right? And you don't want to misspell it. And then I'm going to just pick OK on that. You see where swivel stop is located? What I want you guys to do is to center swivel stop, okay? And so you're going to have to double click on your field text and you're going to have to put some spaces in there, and you may have to try several combinations until it looks like it's centered in there. The scale on this is going to be 1=2 because it's half scale. You'll have the date, and of course all of that's going to be filled out over here in your field text. And this is sheet 1 of 2, and the 5 X's right here are going to be replaced with 28017. Okay, and you guys should remember that because that's your section. So that's going to go in every drawing that you do. So I'm going to close that down. So what I want you guys to do this weekend is to finish dimensioning the swivel stop and get this drawing set up. And then when you come in on Monday to the actual class in room 1530, I'll have a check print for this, and you can run a check print on your drawing that you made over the weekend. Okay, so that is the assignment, is to get this guy drawn and you know, set everything up where you don't have leading zeros and all the things I talked about today. And hopefully you're starting to figure all this stuff out and put it all together. Okay. All right. So I'm going to open it up to questions because I don't have anything else to talk about today since this is the assignment. There will be a new assignment on Monday, and I'll talk about the new assignment on Monday. And it's actually kind of a tough project to do. So if you go to Blackboard, it says you can submit this through Blackboard, but I don't want you to submit it today or over the weekend. I would like for you to come in and look at the check print first and then make corrections to it and then submit it to me, and you can just print it and give it to me and I'll grade it. I'll grade the actual 17:11 drawing on it. Okay. Oh, Jason says it's Tuesday. That is correct, sir. This is Thursday, so our class is Tuesday. Thank you. I do have a Monday class, but it's not you guys. Okay, so I will see you guys at Tuesday at 11:05 and 15:30. I'll have a check print at that time for this drawing. That's the homework assignment, is to get it done. So I'll stick around and answer questions if anybody has any. And otherwise, if you're leaving, I hope you have a safe weekend, and see you on Tuesday.